This is section 1.9, part B, and using systems to model data. In example 4, we have two equations that are already written for us, and they are the amount of student loans since 2000 that are private loans and unsubsidized Stanford loans. So we want to use substitution or elimination to predict when the amount of private loans will be equal to the amount of unsubsidized Stanford loans and what that amount will be. Okay. In any system where I have one variable solved for in both cases, I'm going to want to use substitution. So I know what L is equal to here. I can plug it in for L in the other equation. That's going to look like replacing this L with the expression 3.0t minus 1.0 equals, it's originally equal to 2.3t plus 15.4. It's all in one variable now, so we're ready to solve for t by subtracting the 2.3 from both sides, 2.3t from both sides, to get all the t's on the left. So 3 minus 2.3 is 0.7t minus 1 equals 15.4. Just drop the trailing 0 on the 1.0. Then add 1 to both sides and we get our t. So 0.7t equals 16.4. If you divide both sides by 0.7, that gives us 16.4 divided by 0.7 is 23.43. Okay, the number of places that I round to usually should be 4 if it's going to be a y value, but if it's just going to be an x value, you're going to use t for time. It doesn't really matter how many places you keep. Okay. However, when I go and plug this back in, I'm going to want to have had more places. So I'm going to plug it back in using the original. So I'm going to use L equals, it doesn't matter which equation I use, you should get the same thing. So I'll use 3.0 times 2.43, making myself a note here, minus 1.0, that I'm going to use the exact value on my calculator. Otherwise, I have rounding errors because I rounded that too soon. Okay. So on my calculator, I can just do without clearing. So I can do 3.0 times, just hit up, hit enter on that to bring that whole number down, and then close parentheses, and you can do your minus 1.0. Okay. I want to use the whole number so that I don't incur rounding error by rounding that a little bit too soon for 3 at the end. Okay. If you aren't able to do that, then what you're going to want to do instead, the answer is 69.2857. If you aren't able to use the exact value in your calculator, then you're going to want to write down more decimal places for t. If you want to keep 4 as an accuracy, you need at least 5 in t so that you can plug it back in by typing it instead of it. But the calculator is going to give you a faster way of getting that exact value plugged in. Okay. So for our interpretative part, we're going to have to figure out what year it is, remembering that my t values were years since 2000. So we're going to add 2000 to that. Up here we said we were since 2000. So we're going to say that in the year 2000 plus 23 is just the year 2023. And then this is where the two types of loans were equal. So we're just going to say both private and the unsubsidized Stafford loans awarded, or will, I guess, award, since 2023 hasn't happened yet, are going to award 69.2857, and then don't forget your units from the top, we're in billions. There we go. Okay, let's look at the next one, number 5. In this one, the equation isn't written, so our first step is going to be to write it. So the U.S. market share for Chrysler went from 15.15 in 1999 to 11.17 in 2012. Honda's market share went from 6.18 in 1999 to 9.62 in 2012. Okay. Working by hand, find linear functions for Chrysler and Honda, modeling their respective market shares in years since 1995. Okay, so I'm going to divide my paper in two so I can do on one side the Chrysler and on the other side the Honda model. So for each of these, I need to be able to write two ordered pairs, find slope, find the linear model. I know that my ordered pairs should be in the form of year, comma, percent, or year, comma, market shares. I guess I'll do M for M for slope, so I'll do P for percent. For the percent market shares, because I know the percent market share is going to depend on the year. So that's the order I need these to be in. So Chrysler, their first order period in 1999 was 4 years. Since 1995, comma, that was 15.15. The next ordered pair, 2012. 2012 from 1995 is going to be 17 years. So 17, comma, 11.17. Okay, just go ahead and do Honda's ordered pairs too, and then we'll go back to Chrysler and find the slope. 1999, again, is the year 4, comma, 6.18%, and 2012 is going to be 17 again, and 9.62%. Okay, so in the Chrysler equation, let's find slope. I want to write a linear function, so I need slope and intercept. Find slope first. So y2 is 11.17 minus y1 is 15.15 over x2 is 17 minus 4. Okay, so I've got my 11.17 minus 15.15 on the top. That's negative 3.98 divided by 17 minus 4 is 13. So if I divide that by 13, I get, and for a story problem, there's no way I'm going to make that a fraction. I can't make a decimal over a fraction into a fraction using good numbers. So I need to use a slope that is going to be a fraction. So we're going to try to keep at least 3 places. 4 would be preferable, but we'll do at least 3 on these guys. So we're going to do slope is negative 0.306. Okay. Then, once you've found slope, you need to find y-intercept. So you know that your equation is of the form y equals mx plus b. And remember that once you have m, you plug an ordered pair in for x and for y so that you can solve for b. So I'm just going to take the first ordered pair, plug it in for x and for y, and I'm going to solve for b. So I've got 15.15 equals m negative 0.306 times x, which is 4, plus b. Okay. So that's 15.15 equals negative, or actually I can just use the whole number since it's right there, times 4, negative 0.306, etc., times 4 is going to be 1.2246, so 1.225. It's negative 1.225 plus b, and then I can add 1.225 to both sides. All right. So 15.15 plus 1.225 equals 16.375. All right, I don't have a lot of space left here to write my model, but I'm going to fit it in right underneath the b value. Once I found the m value, remember I had to find both these. I had to find the m value and the b value to be able to write the equation. So my equation is going to be, so percent, or C of t for the Chrysler model, they said I could call it C of t, but it's also equal to my percent for Chrysler, is this, mx plus b, so slope, negative 0.306, I'm calling the x variable t, for time, plus 16.375. Okay. We need to do the same thing for Honda. First, you find the slope. So m equals, we've got 9.62 minus 6.18 over 17 minus 4. 9.62 minus 6.18 gives me 3.44 over 13. 0.265. Okay. Now that we have slope, we need to find intercept. So I'm going to take any of the ordered pairs. I'll just use the first one. Plug it in for x and for y. So the y value is 6.18 equals m, the slope value, 0.265 times x, which is 4, plus b. Okay, so that's 6.18 equals, my slope is already on my screen, so I can just hit times 4. 1.058 plus b, and subtract 1.058 from both sides. Oops. That gives me 6.18 minus 1.058. 5.122 for b. So my model, P, for Honda, so P equals h of t, just two ways of saying the same thing. The percent is Honda's percent in this case. B, the slope is 0.265 times x, or t, plus 5.122. Okay. So we got both of the equations written. Now part B is going to ask us to use these equations to find out when the market shares for Chrysler and Honda will be the same. So when they're going to be the same is going to be when they're equal. So I'm going to set my two equations equal to each other. So negative 0.306t plus 16.375 equals 0.265t plus 5.122. Let's get all our t's on the same side. Let's say we go ahead and subtract negative 0.265t from both sides. That gives us negative 0.306 minus 0.265 gives me negative, I accidentally multiplied, I better try that again. Subtract gives me negative 0.571t plus 16.375 equals 5.122, and I need to subtract the 16.375 to get the t's by themselves on a side. So negative 0.571t will equal 5.122 minus 16.375, or negative 11.253, and I should be able to divide both sides by negative 0.571 to get t. So 19.0708. Okay. Now, I need to plug this into one of my two equations to find what percent they're actually both equal to. I should get the same thing for both of them because this is the point where they're equal. So I can choose either one. I'm just going to choose the Honda one because the numbers are positive and I like them better. It doesn't matter. So if I take h of 19.708, I get negative 2.65 times 19.708 plus 5.122 is, let's find out, 0.265 times, I'm going to hit up, enter on that, so I have the full rounded number in there, plus 5.122, and I get 10.344. Okay. So my conclusion needs to include year. I know that my t value is years since 1995, so you can add that to 1995. It's going to give me a year value of 2014. So my explanation is going to say in the year 2014, market shares for both companies were 10.344%. Okay. Let's flip over to the next one. So if you didn't notice in that last one, if you have data points, especially data points that involve decimals, it's a giant pain to write the equations by hand, let alone having tables with lots of points. So we're going to need to use linear regression to write our tables, especially if there's more than 1 point. But even if there's 2 points, you can use regression to check and find your model. Okay. So I'm going to find the model for the Hispanic population's birth rate and the model for the non-Hispanic white population's birth rate. So I need to enter these first of all into my graphing calculator. So I'm going to go into my stats menu, edit, up, clear, enter, to clear out old data. Okay, I'm going to enter all my data in here, but first we need to know what my starting year is. So starting year, I see since 2000, so we're going to use values for year like 3, 4, 5, again just subtracting 2000 from each of these, 6, 7, and 8. Okay. So these are going to be the T values. I'm going to put these in list 1, and then I'm going to put the Hispanic values in list 2 and the non-Hispanic values in list 3, so I can get them all entered into the calculator at the same time. Okay, 3, 4, 5, 6, 7, 8, and 0.912, 0.946, 0.986, 1.039, 1.0663, 1.041. Next column, 2.322, 2.297, 2.28, 2.309, 2.31, and 2.268. Okay, now I need to find these models. I go into stat calculate for linear regression. Note that the default is list 1 and list 2. And I'm going to want to compare here list 1 and list 2 and list 1 and list 3 to get the Hispanic and the non-Hispanic data. Okay. Now, I actually want to do list 1 and list 3 first because my calculator will remember what I've done last. So if I don't have 3 lists next time I do regression, it's going to remember that I did a list 3 anyway, and I probably will have some error and might have trouble figuring out what the problem is. So I like to do this one first, do that one last because it leaves my calculator in default mode. So list 1, I'm going to change this to list 3 first. List 1, list 2, list 3 are above 1, 2, 3 in blue, so I'm going to hit second L3 there. List 1, list 3, we're going to do that one first, go down to calculate, and this is our model for the non-Hispanic. So I see the A value and the B value. You can ignore R and R squared for right now. We'll talk about those in the next unit. But right now, let's fill in the A value. Because that is so small, I want to keep, well, it does say 3 places right here, so I'm going to keep 3 places. But it's going to be negative 0.006. Let me write this down. Okay, so call this B, or W of t equals negative 0.006 t plus, and if you remember your B value, mine was 2.329. Okay. Now, going back to stat, calculate regression, linear regression, remember, it remembers what you did last, which is why I wanted to do the list 2 1 second. Because next time I use my calculator to do regression, I'm probably only going to have 2 data sets, and I want that to be in there from the previous one so I don't have any errors when I go to do my next regression. Okay. So the Hispanic one, H of t will be 0.0299, so it's going to be 0.030, and then 0.833. Okay. So B or H of t will be 0.030t plus 0.833. Part C and D. Compare the B-intercepts of both models. What does your comparison tell you in this situation? So the B-intercepts are like the Y-intercepts, because we're calling YB here. And what this tells me, as a quick comparison, I just want to look and see which one's higher. It tells me that, remember, intercepts are in your starting year. So in the starting year, 2000, the birth rate is higher for this population, for the non-Hispanic white population. Okay. So there were more white non-Hispanic babies. Okay, that would be what the Y-intercept means in this context. Part D, compare the two slopes. And what does this tell you about the model? Well, the Hispanic population has an increase, and the white non-Hispanic population is a decrease. So I can write that for my comparison as I note that the number of Hispanic babies is increasing, and the number of non-Hispanic white babies is decreasing. As a follow-up on those two, just a note that if you had two lines where you knew that one of them started higher than the other, so you knew that one of them started low and one of them started high. However, you also knew that the one that started high was decreasing and the one that started low was increasing. What it could tell you is that there's going to be an intersection point somewhere in the future. If the situation was reversed, then you would know that there was an intersection already some point in the past. Future being future from 2000. We don't know what year it's going to be, but that is something that we can draw as a conclusion from those two statements. Cool. All right, so now I want to use the intersect feature on my graphing calculator to predict. Okay, as we saw on the back side, it is not the funnest thing to do to solve an equation. I absolutely could do it with these numbers. With the more decimal places, it's just you can't do it in your head anymore. So you have to do more buttons in the calculator anyway. So we're just going to get these solutions by using the intersect feature in your calculator. Now, the directions for how to do that are on the next page. So I just wanted to point that out as well. This is the directions for, let's see, going in list 1, list 2, putting my data in. I'm going to go to y equals. I'm going to turn both my plots on to see my data, and then I'm going to graph both of my models. Okay, if you flip your page, there's lots of calculator directions here. This is the directions for doing the regressions, which we already did, and then if you continue looking, these are the directions for graphing both equations, and what we're going to be doing is finding the intersections. I just want to point out that they are here and we can read them, but I'm going to talk you through them as we go along. Okay? So, a couple of things. First, I'm going to go in and I'm going to, I had some old stuff in here to clear out. I'm going to go in and I'm going to type in my two models. So 0.030 using the variable key up here instead of typing t, so x. Calculator won't like t, has to use x. 0.3, there we go. And the next model was negative 0.006, variable key, plus 2.329. Okay. Got my equations in here. I also want to see my equations on my data because it's a data modeling question. A lot of times you're asked to look at them together. So I'm going to turn on plot 1 and plot 2. And I'm actually going to have you go into table setup to make sure that your plot 1 and plot 2 are set up correctly. Oops, stat plot I meant to say. Stat plot, first one. Plot 1, list 1, list 2. Plot 2, list 1, list 3. So mine are already correct. If your plot 2 is mirroring 1, then you're going to want to change it to list 1, list 3 by just changing those to list 3, using 2nd and 3 to get list 3 popping up there. And you can change the color to whatever you want the color to be. Orange is fine with me. And then I'm going to graph. Before I graph, because I'm graphing data, my plots are on, I want to do zoom stats to start me off. It's going to zoom in on the data. So you can see there is your data, and my first line's looking great, second line's looking great. You can see how well they fit. Remember that they're not going to fit every point perfectly. These ones are a little above, some are a little below, but it goes to the middle of your data. Okay. Now, having the discussion about this fact that our intersection must be in the future is going to help us fix our window, because it's beyond these 2 points, beyond the end of the graph that they're going to intersect. So I manually go to window. I need to go out into the future. I need to extend the x maximum. It's only at 8 right now, so let's kick it up pretty far. Let's go to like 50 just to get it really far out there, and hopefully that's going to show us where the intersection is. Yep. So there it is. I can see it. There's no way I could guess it from the graph, but we're going to go into second, calculate, and option 5, find the intersection. First curve is the first question. You could just hit enter because the first equation's on top. Hit enter on second curve because you can see the second equation is there. When you get to guess, just move it close enough that your calculator doesn't have to work too hard to find it, and then hit enter. Okay, there it is. It says intersection on the bottom and gives you your ordered pairs. I'm going to write the ordered pair down. The ordered pair is 41.56, comma 2.0796, so 2.08. I can't say 0908. Okay. All right. That was what I wanted to do, was find the intersection point. So I did that all on my calculator, and now I need to interpret it. The t value is going to be my year value. These are going to be since 2000. So my interpretation is going to be that in the year 2041, it's halfway through, but it's still in the year 2041 summer. Then make sure when you say what happened, that you say that it happened to both populations. They are the same, right? Make sure that we say something about both or the same here. So the number of both Hispanic and non-Hispanic white babies will be 2.08, and then make sure you find the units, because 2.08 babies doesn't make sense, but it's in millions. So 2.08 million babies. Yay, okay. All right. So if you have any calculator questions, again, there were 3 pages of different calculator directions to go through, and you can ask me about them if you have any questions about them as well. We're going to continue using the calculator in the next example. I've got one more set of double regressions to do, so I'm going to do a list 1, a list 2, and a list 3, and I'm going to do the intersection. I'm going to do all this in my calculator. I'm just going to write the models down. Okay? So I need to do years since 1980 here. We're going to be super efficient when we do this one. Years since 1980, so I'm going to use 8. 1993 is going to be, 13? And then I need 1998, so that's going to be 18.